All right, today's situation is I'm looking at putting some kind of trailer brakes on my logging arch. I do pull the logging arch with the Jeep, and I trust its brakes for what I do with it. But sometimes I tow it with a quad, sometimes I tow it with a dune buggy, sometimes it gets towed by somebody else's vehicle. And putting the heavy weight on it going downhill, I'm worried about jackknifing, especially on a quad where it's going to weigh maybe 10 times the weight of the quad on a downhill off-road. And so I'm going to put on one of my logging arches electric brakes. I got two sister arches, one on another location. But I don't have 12 volts or electrical on a lot of the different vehicles. I usually have a car battery or something kicking around for the cabin or whatever, but I don't always have a connection. And I was going to look at putting in a brake controller, but I really want something I can adjust and it just stays there. I can turn it up and leave it down. I don't want to pinch and twist. I want something very, very robust, probably something I can use for other applications when I'm not using it on the rare occasions for this application. I was concerned about how much voltage I would need to get decent braking, how lineal the braking action would be, how much amperage it would consume at different voltages, to get some idea of how I want to build it. And I think I've come up with a plan. I think I'm going to go old school with a rheostat. It's going to have to be quite a high amperage and a high wattage unit to absorb the, it'll be maybe 6 amps total on the axle, like just over 3 amps per electromagnet. We'll take a look at that. Take a look at how much magnetic force you're getting per volt and watch the amperage reading. And that way I can tow the log arch behind a vehicle with a battery and a cord and an adjuster, and I can turn the brakes up and down as I go down the hill and keep all the braking at the back end where the weight is off the arch. I can turn it up and use it as an emergency brake. It doesn't seem to pull so much power that I got to be concerned about it. But we'll take a look at some of the resistors. The rheostats also are done with the one I've ordered is a 0 to 10 ohm. I think that's a good range for what I want and the power, and rather than having it to turn it 3/4 of the way before you get anything out of it, and then the last little bit gives you everything. Quite a lineal split up of the amperages and voltages. So yeah, 10 ohms, 300 watt, and I have got 10 ohms of resistors, so we can see how much drag there's left on, because the rheostat is either wide open and you're getting full voltage, or when it's turned all the way down, you're getting its rated ohms. I'll be getting 10 ohms when it's turned basically off. It doesn't go off. And so I'll have to have a switch too. So I can turn the brakes off altogether, but when I turn them on, I don't care if there's a little bit of braking action, but I really need it to be almost nothing and then full power. So I get a nice slow range of control of the brakes. Let's take a look at that and see if this is really a viable option for putting brakes on something you tow that isn't really organized for having a brake controller like you would in your truck. Let's take a look. All right, so here you've got the electric trailer brake assembly, a brand new one from Beaver. And we're going to take a look at the amount of voltage we put in to the electromagnet and get an idea of the amperage we're pulling per volt and how much braking you're going to get, and if it's a real lineal thing, and how that all is going to work out. So we'll get this all started up. I have a couple meters checking. One's a clamp-on amp probe, and one is a through the meter one, and then the power supply will also give us one, so we'll definitely get an accurate amperage reading. And if we go up to 1 volt, we're getting 0.27. I was getting 0.29 before, 0.27. And there's almost no grab in the magnet at 1 volt. And just like the equations E equals IR, or voltage equals current times resistance, this is what we would expect to find, that about every volt will give you 0.3 or just under 0.3 amps right up until you get to the nameplate voltage of 12 volts for the electromagnet, which is putting out just under 3 amps. And it seems very linear as far as that goes. You can see now, even at 2 volts, it's starting to stick. It's not enough to activate the arm to get the brakes to start moving. And the amperage is coming up. And at 3 volts, it's definitely sticking more now. And it's not enough to really shuttle the shoes. It's just starting to. It's just starting to move, but there's nothing there really. It's not going to do much braking. There's more friction in the mechanism. And at 4 volts, pulling over just an amp. I don't know if it was the temperature. The other thing too is, so we're pulling in 1.086 amps at 4 volts. If I take this back down, remove the magnet or the ferrous metal from it, we're pulling pretty close to the same amperage whether there's a magnet or a piece of ferrous material here or not. So that doesn't seem to change. And at 5 volts, this is where we sort of see a real difference. Now you've definitely got enough to shuffle the shoes. Still a lot of friction in the mechanism, but you can definitely, it's going to start braking at 5 volts. And at 12 volts, I don't know why we're pulling slightly higher amperages than I did a while ago, but it seems to be about 0.3 amps per volt. And I mean, you're going to lock up your wheels at this point. And so I thought different ways of doing this. I was worried that I would lose too much amperage using this just off of a battery with no alternator running on the quad. And I debated about going with a pulse width modulation so that it wouldn't be wasting a whole bunch of energy in the resistor when you're not braking. So let's take a look at what a variable resistor or a rheostat. This one's not going to work. It's just too low in amperage. It's only rated at 0.78 amps. And the ohms, it's a 220 ohm, which is way more ohms than I need. Let's take this down and put a resistor. There we go. So I have ordered a rheostat off AliExpress that is 0 to 10 ohms. So at 0 ohms, of course, you're going to get full braking, no resistance in the system. And then at the maximum, it'll be 10 ohms, which is what this is. These are two 100 watt 5 ohm resistors done in series, which will give us should be 10 ohms. Ten point two ohms. So the nameplate's accurate on those. And now, this is where the rheostat would be in the lowest setting it can go. It goes from 0, which will be full power, to 10 ohms, which is what I ordered. I thought that would give me a good linear adjustment from 1 volt to 12 volts so I can adjust the braking. And at 12 volts, it's still going to be pulling almost an amp, 0.86, 0.87 amps, which means this is still movable, but it's just enough to start moving the shoes. So the problem is going to be, it's going to be dragging. It's going to be using power and it's going to be dragging. So my thought is, I'll put the brakes on the log arch. I'll run a wire from a battery to a rheostat with an on-off switch. I think there's enough give here that the brakes won't be dragging on too much. And if I turn the brakes on going down a big hill, there'll just be a little bit. And I may put another resistor in line so I increase the resistance even more, so that when you turn it down, you're really getting almost none. It would be nice to have it so that when you turn it down, you're getting no brake action. I don't mind if the electromagnet is consuming a little bit of power, as long as the brakes aren't dragging. And then you can just turn the dial up to basically lock up the wheels. So when you're heading downhill and you've got a big load of logs on your little quad and you're worried about getting jackknifed and crushed, you can just dial those brakes up. And I thought about doing the pulse width modulation and different ways of doing it, but I think for fail-safe safety, when you've got a log on the arch and you're headed downhill on your little 400-pound quad, something simple and easy and zero maintenance that'll still work even if it gets wet is the way to go. And so that's what I'm going to try and build. And this is just sort of the theory behind it and an idea of how to get electric brakes on your trailer if you're running a quad, or maybe you're running something that has no electrical, like my quad's got no electrical left on it, so I can just throw a 12-volt battery and this and adjust the brakes as I'm going down the hill. Well, that's my thought. If you've got better ideas, I thought about actually just using a brake adjuster out of a truck and hooking it up and wiring it up to a battery like it would be in a truck. But I really want to be able to adjust it and basically use the trailer brakes as my main brakes. And I don't want to have to squeeze it, and when I take it off, it turns off. I want it to just be able to turn it on, actually use it as an emergency brake, and have very, very fine knob adjustment, and build it into a box where I can use that rheostat for other things. And so I've ordered a 10 ohm, 300 watt rheostat, and I think that should take care of it. So you just turn it on and you've got minimal or no dragging brake, and then you just adjust it up for full brakes and down, and when you finish your hill you turn it off and off you go again. That's how we're going to get brakes on a logging arch to pull with a quad or a dune buggy or something with no electrical power that a 12-volt battery can stop us. If you got some crazy ideas or you think this is stupid, throw it in the comments. Why not? Thanks for watching.